In this video, we're continuing section 1.3 on propositional equivalences, and we are going to talk about De Morgan's laws. So I want to motivate this with an example. And in this example, I want to express the following statements in another equivalent way. So for part A, I have the negation of the statement or the proposition, I'm tall and I have black hair. So this is saying it's not the case that I am tall and I have black hair. So if we think about that, what would the negation of this be if it's not the case that I'm tall and I have black hair? Well, this means that either I'm not tall or I don't have black hair. Like, it's not the case that I have both of them. So let's write that. So I'm not tall or I don't have black hair. Or I don't have black hair. Okay, so the key connecting word that we're using now is or. Okay, so more generally, if we are negating P and Q, it's equivalent to be saying, well, not P or not Q. So in other words, if it's not the case that P and Q are happening, that's either saying P is not happening or Q is not happening. Okay. So I'm going to highlight this. This is one of what's called De Morgan's laws. This is a logical equivalence. Okay, let's do one more of these. So part B says, it's not the case that I will bike or drive. So if it's not the case that I will bike or drive, well, that's the same thing as saying I'm doing neither of those. I'm not biking and I'm not driving. So I'm not biking. And there's that keyword, and I'm not driving. Okay, I'm not going to bike and I'm not going to drive. Okay, so the key connecting word this time is and. So more generally, if we are negating P or Q, if it's not the case that P or Q happens, well, that's the same thing as saying not P and not Q. Or in other words, P doesn't happen and Q doesn't happen. Okay, so I'm going to highlight that. That is the other version of De Morgan's law. Okay, and finally, I want to end this video by using a truth table to more formally show one of these things. Okay, so I'm going to make a truth table. I'll have my P and Q. And then for the left-hand side, I would first need to do P and Q. Once I do that, I can do the negation of P and Q. For the right-hand side, let's see, I'm going to need not P. I'll also need not Q. And once I form those, then I can do not P or not Q. Okay, so I'm going to create my truth table, separate out these initial building block propositions, separate out my first side, and then also separating out the final side. Okay, so I'm investigating the truth values of this and the truth values of that. And I'm hoping that they're the same, because if they're the same, then these two propositions are equivalent. All right, so for my truth values, for Q, I alternate true, false, true, false. And then for P, I can go double true and then double false. And now I have all four possibilities for what these truth values can be. Remember that P and Q is only true when both of them are true. And that just happens in the top row. Okay, but if either one of them is false, which happens in all these other situations, then the and statement is false. Then to negate it, I just switch all of those truth values. So the top one becomes false, and the three bottom ones become true. So I'm hoping that the right-hand side ends up with those same truth values. So I need to do not P next. So I negate all of P's truth values. So let's see, that gives me false, false, and then true, true. Then I negate Q's truth values, So that is going to give me false here, false there, and the other two become true. And then finally, for my or statement, remember the or statement is now going to combine these two, and the or statement is true as long as at least one of them is true. And that happens in the bottom three rows, at least one of them is true. So I'll get true, true, true in the bottom three. But in the top row, both of them are false. and then my OR statement is false. So because both sides of this, logical equivalence, they have the same truth table outputs, that shows that they are logically equivalent. Same truth table outputs. So these propositions are equivalent, like we wanted to show.